Okay. So the first couple topics are really straightforward. I think it was more of a lot of people just making little mistakes when they actually were doing these on the initial knowledge check. And when they actually look at the topic and look at the notes, it becomes pretty simple. But the biggest thing with vertical and horizontal lines is it's always opposite of the way you would think. So if we look at a graph, that's my y-axis and that's my x-axis. But when we look at a point on that graph, so say I have a point right there. If I was to draw a horizontal line through that point, it hits the y-axis. So the horizontal line is actually y equals, where the vertical line is x equals. So it actually is the opposite of what you would normally think in this problem. So in this one, the vertical line is x equals 0. And the horizontal line is y equals 1. So so that's what you end up getting on that. The other piece in this one is you have to make sure you put the x equals and the y equals in, otherwise it will end up marking it wrong as well. Oh, I said it right and I typed it wrong. X is 1 and y is 0. There we go. That's better. So that's what you're doing for vertical and horizontal lines. So it's not overly complicated with this topic. Same thing. They do switch these up quite often, so do make sure you actually read where it's asking. So y equals -6, and then x equals 5 for that one. All right. Welcome, everybody. I did say this before. I'll say it again because there's a ton more people that came in. I got fed up with WebEx with the actual recording of the stream and other limitations of it. And we can use Microsoft Teams. And I used it in one of my other meetings that actually worked really well. So I figured I'd try it for this. So if this works, we'll probably be using Teams from now on. And if anybody had any trouble with it or anything else, just let me know. And we could figure that out afterwards. But you do have the raise your hand feature. So if you do have a question, just raise your hand and I'll see it. And then I can actually just call on you to ask your question and stuff like that. So it'll be a little bit easier than we did in WebEx. So this one, again, it's using the interval notation, which is why probably some people got it wrong on the initial knowledge check because weren't sure what that notation meant. After the last class, I think everybody gets a little bit better understanding of what the interval notation is. So remember, if it's a closed dot, it's the brackets. If it's an open dot, it's parentheses. Now, this question's asking for strictly decreasing. So you cannot decrease at a specific point. So since it's decreasing, it's going to be all the open parentheses. So since for this one to be decreasing, we're going to be looking at it only from horrible line, there to there, and there to there. So we're looking at it from -5 to -3, and then 0 to 1 is where it's actually decreasing. So we're going to put both of those intervals into the box. Now you're not going to use the U between these. In this topic, you're just putting a comma between the intervals. Yeah. If it said, let's see if I can find one that says constant, increasing. Because if it's I want it wrong. Yeah. If they said constant, so I'll just do this one. I'll show you what it means by constant. The constant one, because you can be constant at a point. So if this was constant, I'd only be looking at the straight lines. And the constant one would be from -1, and it'd be a bracket, -1 to 3, and then 4 to 6. Because it is being constant at that point. It's not increasing or decreasing. So, but I can't find one that's going to give me that question. So, all right. So this one, I'm actually going to use the example so I can show you the different graphs that you can see with this one. This one's looking at what the graphs look like when you actually were to graph them out. Shoot, did I hit the wrong button? So when you're looking at them, this is the piece you want to look at right here. So a constant graph is going to be a straight line across. A linear equation is going to be a straight line going up, down. Constant and linear are very similar in that respect. The constant is just a horizontal line. Absolute value looks like a V, and it comes to a point. So absolute value in parabolas will look very similar, except that the absolute value is straight lines coming to a point, and the parabola is a constant curve. Square roots, you can't have negative square roots. So a square root is actually going to start at a point and go up from there. And it's almost going to make kind of like the exponential type curve, but flatter. And then you have the cubic graph. It's basically flipped over. The parabola, just take the other side and flip it down. Then we have the two rational functions. Your rational functions are going to have an asymptote in them. And your asymptote will typically, in this case, will most likely be at 0. So it's that vertical asymptote right there, because I can't divide by 0. So if it's 1 over x, it's going to go in both different directions. If it's 1 over x squared, they're both going to go to the same direction. So they're going to both go up or both go down. So when you're doing this topic, what I would do is I would either write down or sketch this out in a notebook, or just take a picture of this, and then you can match them up to the actual graphs. So this one, straight, easy line. That one's going to be my linear equation, y equals x. This one's got that asymptote in it, but they're both going to the same one. So I know it's one of my rational ones. And since it's going to the same one, it's the x squared. I've got this one that's just a parabola. And that one is my absolute value. So once you have those graphs down, it makes it a lot easier. This topic is just leading into a bunch of other topics that you're actually going to have to be identifying and using these graphs. So understanding what the graph looks like, even if you use a graphing calculator to do it, will make sure that you know you type the problem in correctly and get the correct graph from it. A lot of times I see people will put things in the wrong spot, especially when they're doing fractions, and the graph, they won't understand what the graph's supposed to look like, and they'll just think it's correct and put it in, and then make a mistake on it. So understanding what those graphs look like is actually kind of a very important piece of it. So you've got, this is the parabola. This one right here, it's going to start at 0 and it's going up. That's my square root one, which we're going to actually look at a lot tonight. We've got this one. This one's another, I have the vertical asymptote. So this one's a rational function and they go different directions. So it's 1 over x. And then that's the linear one. So that's just x. All right. Any questions on those? Hold on 1 second. I'm actually going to stop sharing my screen for a second. Because I'm just going to hop over to the WebEx meeting because I think some people are over there, and just tell them to come over to check their email. Hello. You guys should have gotten an email, or if not, go look at my website. I'm not going to use WebEx. I have a Microsoft Team meeting, which is going to work a lot better, I think. So just go to my website real quick and get the link there and hop over into the Microsoft Team meeting. And it's also in your email too. So either one of those two will work. Back to this. All right. Okay, so moving on. Let's look at the next question. Now, the next couple questions are going to look at identifying functions. The difference between a relationship and a function is a one-to-one relationship. So that means every input, everything in the domain has exactly one output in the range. That output can be the exact same thing as all of them, but it's still a one-to-one relationship. So the easiest way to explain this, if we use a sports example, is if I asked you for a baseball team in the American League, that's not a function because you can give me a bunch of different baseball teams. Up here, Yankees, Red Sox, like you can give me a bunch of teams and I wouldn't be able to predict your answer. However, if I was to ask you what league the New York Yankees are in, I can predict your answer. It's the American League. There's only one possible answer for it. So that way would be a function. So it's a one-to-one relationship. So at any time, if one X value in the graphs have two different answers, it is not a function. So what we actually use what's known as the vertical line test. And so the vertical line test basically says I take a line and I go across the graph. If at any time it hits it more than once, it's not a function. Now, right here, I hit those two lines more than once. However, one's an open dot and one's a closed dot. The open dot doesn't count because it's just getting really close to that one. So that still would work. Even though there's a gap here, that's fine because there's no actual answers in the domain that would work there. And then that one. So this one is a function. Now, if I go over here, oh, I've hit the graph twice. Not a function. This one, I've got the point there, point there, point there, point there. That one is a function. Oh, right there, I hit 2 points. Since I hit 2 points, that's not a function. This one, I go all the way across, never hit it more than once. So that is a function. This one, I hit it more than once. Not a function. So quick, easy way to use it. On your screen, just use your pencil and go across if you want, or if you can just visually look at it. So, but yeah, that's how we're looking for vertical line tests in functions. I'll try one more just because sometimes, yeah. So first one, not a function, is pretty easy. This one hits there, it's not a function. That's not a function. That's a function. I wanted to show you one like this. So remember the other one had an open dot? So that open dot's fine, but it's not a function because it hits twice here. The open dot and the closed dot didn't line up. So this one is not a function. And then that's just a parabola. So that's a function. All right, so this is just a, so we looked at the graph method. And now we're looking at the relationship, looking at the domain and the range aspect of it. Remember I said one input to one output. So this one, cloud, goes to two different answers. It could be one or negative one. So right there, that's not a function because I have one input to two outputs. Relationship 2. 4 goes to everything. So that's not a function. Now, when they give you the points, it's a little harder to see. You're looking at the x's. So if any of the x's, if none of the x's repeat, it's automatically a function because not one input goes to the output. So I have R, H, N, and U. So none of the x's repeat. So that's a function. Even though they all go to the exact same, well, the first 3 all go to the exact same range, that's fine. It's all about the input. So in this one, I got 7, -2, -2. Okay, so -2 is twice. So -2 goes to S and 1 goes to G. So that's not a function. If they both went to S, that would have been a function. So that's why you have to look at it, because sometimes they will put them both in there. It'll be like a -2S, -2S, and that would be a function. So it's a little way they could be a little tricky on it. Let's try one more of these. Let's see. Yeah. So this one, my domain, every one has just one line coming out of it going to one thing. So that's fine. That's a function. This one, 1, 1, 1, 1, 1. So that's fine. But notice how these two both go to 4. That's okay. That's acceptable. So that is a function. Just look at the domain. Everyone only has one line coming out of it. F, M, M, F. So F is, M is twice. So I have an F and an M. So that's not a function. -2, -7, -7. So -7 appeared twice. I have an X and an F. So that's not a function. All right. All right. Any questions on identifying functions and the relationship? Or is everybody good there?
Can you do that again?
Sure. So you're looking at the domain. So it's one domain to the one range. So this star goes to -8. That's fine. Cloud 2. Rock 6. Sun 6. Everyone only went to one thing. So that's fine. That's a function. So the other way to look at it is, can you predict the answer? So if I told you rock, can I predict what you're going to tell me as the answer if you tell me the correct answer? And I can say yes, because I know you're going to tell me the answer is 6. There's only one possible answer. Now this one over here, it's if I told you 2, you could tell me -7 or 6. So I can't predict your answer. So that's not a function. So functions got to be predictable. One input to one output. And then we have M, H, Z, Y. None of them repeat, so that's a function. 0, 0. Okay, so 1 goes to T, 1 goes to C. So that's not a function, because 0 wouldn't be predictable. And actually 0 also goes to M. So as soon as it's not predictable, it is not a function. All right, so now we're going to start getting into some more of the graphing stuff. So the graph of a parabola, we have some basic information about our graph of the parabola. The key pieces of information. Correct. For a function, you cannot have more than one range element corresponding. Exactly. That's a very good definition of it. So that point right there, that's my vertex. That's going to be the highest point in the graph or the lowest point in the graph, depending on the direction that the graph is going. We then have our X-intercepts. So you could have 2 X-intercepts, 1 X-intercept, or no X-intercepts, depending on if the actual parabola crosses the x-axis or not. So if the vertex is on the x-axis, you'd only have 1 X-intercept. Then we also have our Y-intercept. you will always only have one y-intercept for a parabola. So a parabola always has to cross the x-axis or y-axis. You'll always have one of them. You'll never have more than one. And then the last thing we have is our axis of symmetry. So our axis of symmetry goes directly through the vertex. So that's my axis of symmetry. So those are the key pieces of information in a parabola, is those pieces. So this question is asking you, does the parabola open upward or downward? So upward would be a happy face, downward would be a frown. This is downward. It's the easiest way to remember it. My vertex, so that's that point right there. So it's at 4, 2. The axis of symmetry is x equals. So it's always, it's a vertical line that goes through the x-axis. So you have to put x equals, and it's going to go through 4. So it's always the x value of your vertex is your axis of symmetry. That axis of symmetry is very important because that gives me the middle of my graph. So if I only find pieces on one side of it, I can reflect it over to the other side. So it actually saves me work when I'm actually going to be doing the graphs out, especially if we're doing them by hand. X-intercepts is 2 and 6. If we were to have the equation for that, those would be the factors. So your x-intercepts, your factors, your zeros, your roots, all mean the same thing in terms of a parabola. It's all where it actually crosses that x-axis. And then my y-intercept is -6. Let's see, one more. I want to see if they give you one with none. Yeah, so this one, very similar. They do move the questions around, so just make sure to put them in the right spot. So this one opens upward. My x-intercepts are -2 and 6. My y-intercept is -3. My vertex is 2, -4. And my axis of symmetry is x equals 2. Any questions with pulling information off the graph of a parabola?
How did you get the y-intercept?
It's where it crosses the y-axis. So in this case, if I zoom in a little bit, you can see it crosses the y-axis right there at -3. Same thing with the x-intercepts. The x-intercepts are where it crosses that x-axis. You'll always have one y-intercept. The x-intercepts could be 0, 1, or 2 intercepts, actually. All right, now we're getting into some of the graphs. So the next 3 problems that we're going to look at is all graphing of piecewise functions, which is probably not something that any of you have actually really done before. So piecewise functions are basically just multiple equations graphed together in the same graph. The key piece is you have to look at the domain to determine where you're going to graph it. So in this one, it's 2 where x does not equal 0. So basically that's everywhere except for 0. So I'm going to draw a line everywhere. And I'm going to put an open circle at 0. Because that line works everywhere, it's 2, except when x is 0. And now when x is 0, the answer is -1. Does that make sense? This is the hard part. This is virtually, it's going to be a little more complicated to gauge your views. All right. So Yeah, I'm going to do a few more of these. But I want to try to figure out another way to explain this so you can get this one. So basically, if you're looking at so normally when we graph things, we graph them with tables. So if we do a table for this one, let's do -2, -1, 0, 1, and 2. So my answer for -2 is in this one. So the answer, I should change my pen color, is going to be 2. The answer for -1 is in this one still. So the answer is still 2. 0 is here. So the answer is -1. 1 is in that first one. So the answer is 2. 2 is in that first one. So the answer is 2. So that's why that line goes all the way across, because every other number except for 0 is 2. And that's why there's an open circle right at that 0, because when x is 0, which is on the y-axis, it doesn't work. And the real answer is not at -1. So that's why we drew it that way. So let's do a different one of this one and see if they check this one. We'll come up with another one. And the next two topics are the same. It's just they just get more complicated. So, all right. So this one, this is known as a step graph because there's a bunch of them. So let's graph this first one. So basically, this first line right here gives me 2 points. It gives me the -3.5 is my x, and my y is -1. And then it gives me my another point is -2.5, and my y is -1. So those are the two endpoints of my graph. So I'm going to put a open dot at -3.5 and -1. And I'm going to put a closed dot at -2.5 and -1. And then I'm going to connect those dots. So the first one's an open dot because it was just less than. So that's an open dot. The next one was less than or equal to. So it's a closed dot. If you look at the domain right there and how it's written. Does that line make sense to everybody?
No.
All right. So whoever said no, don't take this. Don't be mad. I'm going to use you to do the next point. So if we're looking at the next line, what do you think my first point's going to be in the next line?
Um.
So look at the pattern that I used in the first one. Where did the -3.5 come from?
I -2.5 and 1, -1.
Almost. So your next point is going to be -2.5 and 0.
Yeah.
So my first point is going to be at -2.5 and 0. And what's my next point going to be at?
-1.5 and 0.
Yes. And then we connect those two dots. Good. Does that make a little more sense?
Yeah.
All right. So now the next one, we're going to keep going. The next one's going to be the -1.5
And 1.
and 1. And then -0.5 and 1.
Yeah.
And we connect our dots. Oh. All right. This is where reading comes in and you're looking for patterns and not noticing it. What do you notice? So right there, they switched. Right, exactly. They switched it. So it's not an equal to anymore. It's just a less than. So that one actually should have been an open dot, not a closed dot.
Okay.
So now the next one actually has the open dot. Hold on one second.
Sure.
All right, so the next one is going to be a closed dot at negative 1.5, and it's going to be at 2. And then an open dot at the 0.5 and the 2. And then my final one, wait, did I put something else in there? I didn't. Line, okay. And then my final line is at 0.5 and 3, and then 1.5 and 3. Yeah, so less than is an open dot because it doesn't have that. So the equal underneath it is what decides if it's closed. So since the less than doesn't have that little line underneath it, it's just the open dot. If it has that little line underneath it for the equal to, that makes it the closed dot. So this is known as a step function. Yep, so this would be a function because every one of them, the closed dot and the open dot line up. So this does actually work out to be a function. If we had two closed dots right on top of each other, then it wouldn't be a function. And as you can see, you have to really be careful because they switch things up sometimes. So it's not always open, closed, like we were doing originally. Open, closed, open, closed, open, open, closed, open, closed, open. Maybe 3.5, 2.5. I'm just trying to figure out where I made the mistake now. Okay, 1.5. -1, 0. The beauty of the internet. Let's see where. That's exactly what I have. All right, one of my points may be just a little off, but that's what I have. Okay, it's fine. All right, this one's a good one. Yes, we will be using greater than or less than in these problems, just like the one that's on the screen right now. So that's why I wanted to do at least one more of these. So the same rules apply. So if it's greater than, it's still going to be open dot or closed dot if it has that little line underneath it. So in this one, we're going to graph this one each line just like we did the other one. So this one, it says 3, but it says x is less than 1. So that means, and it's going to be an open dot at that point. So I have my x is 1, and the answer is 3. And then it says it's less than that. So that means my line is going all the numbers less than that. All right, so that's how I'd graph it. So basically, so if you want to do it like we were doing before, you would come up with a couple points that work. So this line right there, the first point they gave me is the 1 and 3, and that's going to be an open dot. And now, as long as I pick another number that would work, so let's do -2 and 3, and that's a closed dot because that's not at one of my endpoints. So I could put a closed dot there. So, and then I would draw my line through that because it keeps going all the way down. It never actually ends. So there's not two endpoints like in the last one. There's only one. So that line is going to keep going. My next one, since it's equal to, only has 1 point. So when x is 1, y is 1. So that's that point right there. And then my final one, I'm going to do the exact same concept. I'm going to use and make 2 points. So the first point I'm going to use is 1, -1. And then I just got to pick another point that will work. And that's going to be an open dot because it's not equal to. And let's do 3 and -1. And that'll be a closed dot because it's not one of my endpoints. So I have 1, -1. And then 3, 1, -1. And that one's going to keep going because it's only got one endpoint. So it keeps going all the way over. So that's how this piecewise function would be graphed. Sometimes the piecewise functions, the first one is actually the hardest one because they're basically all straight lines, where the next 2 ones use linear equations and quadratic. So it's a little more what you're used to with graphing of lines. So is it becoming a little more fixed? Making a little more understanding out of it? Yeah, I'm not gonna do another one of these. I'm actually gonna do another one in the next topic. There's still piecewise functions, but it's with linear equations instead. So it might make it a little, you might understand it a little bit better. But the next 2 questions are all both piecewise functions again. So yeah, so as long as you're picking numbers in the domain, it works. And actually that's what I'm going to do for this one. So you always want to use the number they gave you. You always want to use the endpoints that they gave you. If they give you 2, use them both. If they only give you 1, you need to pick another one in that domain to be able to draw the line because you need 2 points to draw a line. So let's look at this one. So I've got 2 equations for this one. So my first equation is x minus 2, and they're saying that's x is less than -2. So I'm going to use -2 as one of my points. So one of my points is going to be -2. So -2 minus 2 is -4. And since it's less than, that's an open dot. And now I'm going to pick just another number that works here. So let's do -3. So -3 minus 2 is -5. And since it's a point I picked, it's a closed dot. So now we graph it. So I have an open dot at -2, -4, and a closed dot at -3, -5. And since it has one endpoint, I'm going to use the line that has one endpoint and graph it. So that is the graph for x minus 2. Does that part make sense? Okay. Now I'm going to do the other equation. So color. So I'm going to do the 3x plus 2. And this one is x is greater than or equal to -2. So same thing. I'm going to use the -2 because that's the point they gave me. I'm going to plug that in. So -2 times 6, or -6 plus 2 is -4. Now that's a closed dot. And then I'm going to pick another point that works. And I'm going to use 0 just because I like 0. So it's 0 and 2. And that's also a closed dot because that's the number that I chose. So this one's a closed dot because it has that equal sign under it, where this one was an open dot because it didn't. So now I'm going to graph this. So I graph my closed dot at -2, -4, and I do a closed dot at 0, 2. And I'm going to connect those dots now. So those 2 dots. So that's how the piecewise function ends up looking when I graph both lines. Does that make sense? Sometimes looking at harder ones actually makes a little more sense than the easy one. The simpler equate graphs. The next part of this question says, is the function continuous? Continuous means that from one end to the other, you go across, there's never a hole or a gap. So in this case, there's no holes, no gaps, so the function is continuous. All right, let's try one more of those. The other thing I missed from an actual class is I would normally say, here, do this one, and walk around and actually see you guys actually doing it on your paper, which I can't do virtually. All right, so we've got negative 3x minus 1, and its x is less than negative 1. So I'm going to use negative 1. I plug that in, and I get 2 as my answer. And that's going to be an open dot. And then I'm going to plug in, let's do negative 2. So negative 6. So 6 minus 1, so that's 5. And that's going to be a closed dot. So we've got an open dot at negative 1, negative 2. Oh, not negative 2, positive 2. And then a closed dot at 2 and 5. And then we draw our line that way. Much better. All right, so now I'm going to do the next one. So I got the negative x plus 1, and this is x is greater than or equal to negative 1. So again, I do the same thing. I plug in the negative 1. I get negative 1, 2, and that's a closed dot because of the equal sign. And I'm going to do 0. I get 1, and that's a closed dot because it's not one of my endpoints. So graph those. So negative 1, 2, and 1, 0, 1. Now, I will say these two examples, the endpoints were the same. That is not always the case. That's why this question's here. This one is also continuous because it keeps going. They are not always continuous. Let's see if the next one, if it's not going to give me a continuous one, I'll do that one. 2. I also get negative 2, so no. So let's see if I can get one that's not continuous before I go on to the next one. Three and 3. So they're all seem to be coming out continuous on me now. If it didn't come out to be continuous, you'd get a graph that looks, so you could have a graph that looks like this, where you have an open circle, and it would look like this. And then you'd have a closed circle, and it looks like that. So it could like that. That would not be continuous, because at that point they'd come out to be two different things, and you'd say no to being continuous. So that can happen in this problem. It's just for some reason I'm not coming up with one that actually does have to happen. So, all right, are we a little more comfortable now that we've seen the linear equations? Because the next one doesn't get, the next one just adds in parabolas. Taking the deafening silence as a yes, we're good. Moving on. All right. So this is so that was piecewise functions type 1, type 2, and this is type 3. So type 1, simple equations. Type 2 adds in the linear. Type 3 typically will give you 2 or 3, and it will always have a parabola one in there as well. So again, the same thing. We're going to graph the 3 lines and we're going to kind of put them together so they kind of work together. So if there's 2 open dots at the same position, it would not be continuous. If they were both open dots, you would not have a continuous graph because there's a hole there. The ones we did, we had an open dot and the closed dot kind of filled that up when we did the other graph. But yeah, 2 open dots is not because there's a hole in it. All right, so let's look at each of these. So let's do the x squared plus 1 first. So when you're graphing a parabola, I believe when you do this one, you need the vertex up. Yeah, so you need 3 pieces of information. You need to know the vertex, you need to know if it opens up or down, and you need to know one other point. So if it opens up and down is based on the number, the leading coefficient. If the leading coefficient is positive, it's up. If it's negative, it's down. So in this case, my leading coefficient is 1. So since A is positive, it's up. If A is negative, it's down. So this one's positive, so I know it's opening up. Now I got to find my vertex. So what I always do is I just find my axis of symmetry. So my axis of symmetry is x equals negative b over 2a. And if you don't remember, a parabola, the standard form of a quadratic equation is ax squared plus bx plus c. So this gives me my x value. So in this case, it's 0 over 2, which is 0. And then I plug that into the problem. So my vertex is 0 and then 1. And then I just need one other point. So just pick one other point on it. So I'm just going to choose 1, plug that in, and I get 2. So we graph this one. My vertex is at 0, 1. It's opening up. And my next point is at 1, 2. So there's my parabola. Now, the other reason I chose 1 was because that was the endpoint they gave me. That endpoint is less than. So it's not a closed circle. So it's an open circle. So I'm going to put an open circle there. The next thing we have to do is the graph stops there. It doesn't keep going. So I have to use my scissors and cut it. So I'm going to put the point in where it cuts. So it cuts it at 1 and 2. And then we can cut one, 2. Oh, use the eraser. Then you can erase the other side of the graph. So you put the scissors in it to tell it where to cut, and then you can erase the other part of that graph. Don't worry, I will show you again. All right, so graph the parabola. We got our point. So 0, 1, up, 1, 2. So we've got my graph. I then, since it's not equal to, I'm going to put an open circle at 1, 2. I then have to remove everything after that point because it's only the stuff before it that I want. So using the scissors, I put in 1, 2. And then I erase what's after that point. I cut it at 1, 2, not because it was a point, because that's where the endpoint that they gave me was 1. See how that's the number they gave me for my endpoint? That's why I plugged in 1 when I chose the number over here. That's why I used the 1. If they had given me the endpoint as 2, I'd have plugged in 2 here. So that's the point I would have used for the endpoint. The next line Yeah, and it's in this case it's not because it's an open dot. It actually could be a closed dot. This case it's an open dot because there's not a little equal sign underneath it. Now the next line, it says 2 is if x equals 1. So that line right there, that's 1 point. That point is just 1, 2. That's that point right there. So that's going to be an open or a closed dot at 1, 2. So now I'm going to put my closed dot there at 1, 2. And now I got to graph the last one. Now I got the 7 and 5x, and that's x is greater than 1. So I'm going to use the 1. Another number, so let's plug in 2. So if I plug in 2, I get -3. Is my next point. So the first one is an open dot, and the next one's a closed dot. So since I already have hold on a second. Let me try something real quick because it's all right. Does this mic sound better? I know it actually sounds different because I'm actually on my webcam mic now instead of my headset mic. Okay, we'll use this one now. I'll figure out what's going on with the other one later. So this one, I got the 7 minus the 5x, so I got those 2 points. So since I already have an open or closed dot at 1, 2, I don't need to put an open dot there now. I'm just going to leave that point there. But I do need to graph the other one. So my other closed dot's at 2, -3. So I'm going to put that dot there. Now we connect the dots. So this graph, that's a piecewise graph. It looks crazy, but that's a piecewise graph. And it is actually continuous. There's no holes in it. So I would say it's continuous as well. Yes, the graphs can't lead off each other, and I don't know why it's wrong. I'm going to find out in a second. Oh, I put my vertex in the wrong spot. It's 0, 1, not 0, 0. That point right there, that should be right there. All right, let's do one more of these, and then we'll go on to the next set of problems. Oh, good, this one's only got 2. Makes it a little easier. All right, so the first one's my parabola, so I got the 1 minus x squared, and x is less than 1. So my vertex or for this one, is again going to be x equals b is 0, so it's going to be x equals 0, so it's 0. I plug that in, so my vertex is again 0, 1. Now, when I plug in the 1, so I'm going to plug in that endpoint there. So my other point is 1, and it's actually 1, 0. Let's plug in 1 there, 1 minus 1 is 0. And this graph is going to open down. So I do the 0, 1, and then the 1, 0 down, and then the 1, 0. And I'm going to put an open dot at the 1, 0. And then I'm going to cut at the 1, 0. So that becomes my parabola. Now my next one, I got the negative 2x plus 2, and x is greater than or equal to 1. So if I plug 1 into this problem, I get 0. And then plug another number that works, so we'll use 2, and we get negative 2. So my 2 points, so I have a these are both closed dots. So I have a closed dot at 1, 0, which fills in that one, and then at 2, negative 2. So we're going to graph my line off that one. And this is a continuous functions. So yes, in all the examples I've done, they've all been continuous and they've worked. I will tell you that is not always the case. As much as it looks like it's the case in all the ones I've done tonight, I have seen situations where they do not connect. So if they don't connect and you know you did everything right, that is actually a possibility in this problem. All right, let's move on to the other stuff. All right, so this one, actually, I've already kind of talked about it. So this one, there's 2 topics. One deals with absolute value and one deals with parabolas. They're actually the exact same concept. The leading coefficient tells you if it opens up or down. So if the leading coefficient is positive, the graph opens up. If the leading coefficient is negative, it will open down. So A and B are both positive because they open up. C and D are both negative because they open down. The bigger A is, or the bigger the coefficient is, the skinnier the graph is going to be. The closer to 0 A is, the wider the graph is going to be. So where it says the coefficient with the least value, that's going to be the biggest negative value. So that means a skinny graph that's negative. So in this case, that's going to be C. The closest to 0 is going to be the widest graph. So in this case, the widest graph is actually B. Does that make sense? Okay. We're going to look at the exact same thing now with parabolas, because it's exactly the same concept between absolute value and parabolas. So down is negative, up is positive. So down, up, down. Closest to 0, that's the skinniest graph, or I mean the widest graph. So the widest one out. So in this case, it's D is my widest graph. The greatest value would be the skinniest positive one. So in this case, it's B. All right, so the next couple topics are about transformations. So there's actually quite a few transformation topics. These are the two that people seem to have the most trouble with. So the key with transformations is what are you actually transforming? So inside, so we have the y equals f of x. If I'm doing something inside, that's being done to the x. If I do it outside, I'm doing it to the y. So in this case, I have negative x. So I'm going to look at my two endpoints on this graph. So I have my endpoint at -4 and 7, and my endpoint at 4 and 3. The change for this problem is f is negative x. So that's on the inside. So I'm going to change my x values. So this becomes 4 and 7 and -4 and 3. So all I'm doing is I'm changing the signs of my x value. So when I graph it, I put a point at 4 and 7 and -4 and 3. And then I connect my dots. So I think a lot of people, when they look at reflections, they say, oh, it's the x, so they're reflecting over the x-axis. You're changing the x value, so you're actually reflecting over the y-axis, not the x-axis. Does that part make sense? We're going to do the next one.
No.
All right, so notice how it has the negative inside the parentheses?
Kind of.
All right, see how it says f of negative x in the problem?
Yeah.
All right, so that means, so that's changing the value of the x value. So whatever my x is, I'm going to change its sign. So the first point here was -4, 7. So since that negative is next to the x, that -4 becomes a +4.
Okay.
The other point was a +4, 3. So since it's a +4, that negative x tells it to become a -4.
Okay.
And then I graph them. Now I'm going to do the one on the outside. So notice how this one has the negative sign on the outside. It's not on the inside with the x. So this means I'm going to change the y values. So for this one, I have -g of x. So this one, I have 3 points. So I have -4, 5. I have 4, 1. And then I have 7 and 4. So I'm going to change all my y values. So this becomes -4, -5, 4, -1, and 7, -4. Because that on the outside says change y. So outside is y, inside is x. So that, we graph these. So I got -4, -5. I got 4, -1, and 7, -4. And then I connect the dots. So the key with transformations is looking at inside and outside. Inside x, outside y. The next one combines a lot of things, so I'm going to spend a little more time on the next one, but it's very similar. It's still transformations. Yes, that's what we're going to do in the next one. All right, so notice how this first one, I have f of -x plus 1. So inside is my change in x. Outside, so that's my x1 I'm doing, and that's my y. So my 3 points for this problem I have is -2, -4, 0, 0, and 4, -2. So the first thing I'm going to do is see how the negative x is there? So I'm going to change my x's. So I got 2, -4 now. 0 doesn't change. And -4, -2 as my new 3 points. Now, this one has 2 changes though, because I also have that +1 outside. So I also have to do y +1. So I'm going to make one more change. This time I'm adding 1 to the y. So it's 2, -3, 0, 1, and -4, -2, or -1, sorry. So there's a lot of people that will try to do this topic and not write out the points. I will tell you right now, that's the hardest thing in the world to do with this topic. If you understand it completely, piece of cake. But if you struggle with this topic, writing out the points is the easiest way to do it, and doing one change at a time. Because when you're trying to do all the little changes in your head and moving it, it's really easy to make one little mistake, and then you have to redo the whole topic again. And kids can, or students and adults and everybody can get extremely frustrated with this topic because of that reason. So doing them in the 2 steps kind of helps. And I'm going to do this one, and then I'm going to actually do 2 more of these because there's one other one I want to show you. So I'm going to graph these points. So I got 2, -3. So 2, -3. Then I got 0, 1. And then I got -4, -1. So I'm just going to erase. And that's my new graph. So I changed the signs of my x's, and then I added 1 to my y's. All right, let's look at the next one. So this one's y equals 2 t of x minus 3. So notice how they're both on the outside. There's nothing on the inside. So I'm making both changes to the y. So I'm going to write down my 3 points. So I have 0, 0, 2, 4, and 0, 4. Oh, sorry, 4, 0. So 4 and 4, 0. That's better. So now I'm going to change my y's. I'm going to do it in 2 steps. The first one, I'm going to do 2 times y. So this one's still going to be 0, 0. This one's going to be 2, 8. And this one's going to be 4, 0. So I'm just multiplying my y by 2. The next step, I'm going to do y minus 3. So this becomes 0, -3, 2, 5, and 4, -3. And now we graph those 3 points. So I've got 0, -3, 2, 5, and 4, -3. Does that kind of make sense? I'm not looking for 100% yet. All right. do one more of these. Hopefully it gives me perfect. All right, so this one, and this is why I wanted to do at least one more, because this one is the tricky one. Notice how there's something inside and something outside. So this is being done to the x, and that's being done to the y. Now, if I was in class and I asked every single person here what I'm going to do to the x, I'm willing to bet every one of you would tell me I'm multiplying the x by 2. And that would make sense because it says 2 times x. And that's what people do in this topic, and they get them wrong. Because you actually do the opposite of what it says. So if it's inside, you're doing the opposite of what it says. So in this case, I'm actually going to be doing x divided by 2, not x times 2. So another quick example of that is if I had one that said h of x plus 2 inside, I would actually do x minus 2 when I do it. Because it's always the opposite of whatever it says inside. The only time that doesn't happen is when it's a negative sign, because that is, by definition, the opposite. So you're always doing the opposite of whatever operation is inside the equation. So now let's actually do it. So same thing. I write my 3 points down. So 0, 0, 2, 4, and 4, 0. And now I'm going to do my 2 changes. Yeah, so yes, it's only for the x values. And if it's negative x, you're just changing the values to the opposite sign. So that by definition is the opposite. So that's why it's not different. When it's 2 times x, you're doing the opposite operation. So you're doing x divided by 2. So if it said negative 2, yes, you would actually do exactly what you just did, that, negative x over 2. I will tell you, you'll never see one like that in this topic. But that is true in case of an example that would come up later on. But it won't happen in this topic. So I'm going to take all the x's and divide by 2. So 0 is still 0. 2 becomes 1. And 4 becomes 2. And now I'm doing exactly what it says to the y. So it says plus 4, so I do y plus 4. So it's 0, 4, 1, 8, and 2, 4. So now we graph those 3 points. So 0, 4, 1, 8, and 2, 4. And connect the dots. Okay, I was gonna say I was looking. I'm like, where did the 1, 5 come from? I will tell you right off. There's as you've noticed in a couple of other problems, there are times I will absolutely make little mistakes like that. I have no problem with you calling and saying, "Hey, it's supposed to be this." Totally okay with me. I make flaws and mistakes just like you guys do, and we keep learning from them. So that's why, like, when you said that, I started looking. I'm like, just making sure I didn't make a little mistake. So yeah, so that's should have come up to be those points there. All right, so now the next one, I've got negative g of x minus 1. So my 3 points, negative 2, 4, 0, 0, and 4, 2. I've got 2 things I'm doing to the y. Order of operations counts. So since I'm doing a multiplication and a subtraction, if you do it in a different order, you will get a different answer, and that'll cause you to get things wrong. You want to follow the order of operations. So multiplication comes first. So I'm going to do the negative y first. So my first point is -2, -4, 0, 0, and then 4, -2. And then I'm going to do the y minus 1. So I got -2, -5, 0, -1, and 4, -3. So -2, 5, 0, 1, and 4, -3. And it's always nice when it comes up and says it's correct. All right, so this topic's asking you to write the equation based on what they gave you with the transformations. So they're going to always start you off with the equation. So they gave you f of x equals x squared. I'm always going to rewrite this with parentheses around the x. So now you have to look at your x change and your y change. So this graph moved over 1, 2, 3, 4 spaces. So it added 4. Remember, the x is always opposite, so it's x minus 4. Since it moved +4, I put a -4. Since it moved up 2 on the outside, I'm putting +2. So opposite, so that way is negative, and that way is positive. And then that's the same. So up is positive, and down is negative. So parentheses x minus 4 plus 2. It doesn't matter if it's a absolute value, a parabola, square root, anything they give you. It's the same concept. So this one, the f of x was the absolute value of x. So I'm just going to leave a space inside there. We moved -3, so it's +3. And then I moved up 2, so it's +2. So left and right's inside, up and down is outside. Same concept with the positives and negatives. So we got x + 3 + 2. Let's see if they give me a square root one. Yeah. Same thing with the square root one. So square root x, I'm going 1, 2, 3, so that's -3, so it's a +3. And then on the outside, I'm going down 4, so it's -4. The one thing you do want to do when you're doing your square roots, when you're typing them in, is you want to be careful that you don't do this. Notice how the -4 is still underneath the square root? I don't want that. So you have to use the arrow key to get out and then put the -4. Just make sure the -4 is not underneath that square root.
Can you explain this again?
Can I explain what?
This problem.
Yeah, so it's what we were doing before with the transformations. You're just doing the equation. So we're moving from here to here. So I moved over 3 to the left. And remember, and if I go back a couple, remember, it's opposite. So left is positive. So that's where that +3 comes from. And since it's to the x, it's on the inside with the x. And then I'm going down 4, so that's on the outside, and that's the -4. That makes sense?
Yeah.
Okay. All right, two more, and they're basically the same topic. All right, so when you're graphing square root equations, the key with graphing square roots is what numbers you're using. So you always are going to want to start off with just looking at the square root problem. So just the square root of x. So I'm going to make my table. So this is known as graphing the parent function. So since square roots are one of those ones that there's very specific numbers that work, that are going to give me a nice answer, I don't just want to use random numbers because I'm going to get decimals and fractions, and I don't want to do those. So 0, I know the square root of 0 is 0. I know the square root of 1 is 1. I know the square root of 4 is 2. And I know the square root of 9 is 3. So I'm going to use 0, 1, 4, and 9 because those are really easy ones to do. Notice, however, this problem is not just the square root of x. This problem is the square root of x minus 6. So what we're doing is that minus 6 is on the outside. So all I'm doing is I'm taking my answer from this and subtracting 6. So this becomes negative 6. That becomes negative 5. Becomes negative 4. And that becomes negative 3. So my points that I'm going to graph, when I graph my points, is I'm going to graph 0, negative 6. 1, negative 5, because those are the answers that I want. 4, negative 4. 9, negative 3. And then I hit the little curve button, and it puts my curve in. So if you think back to what we did with the transformations, in essence, what we're doing is we're taking the parent function and we're making a transformation to it. So since it's on the outside, I'm changing the y values by subtracting 6. Let's do one more of those, and then we'll do the harder one. So now this one, again, I'm still going to use my same parent function. So I'm still going to use the square root of x. So I have x, y, I have 0, 0, 1, 1, 4, 2, and 9, 3. But now this function, it's underneath, and it's minus 4. So remember what we said with the transformations. If it's inside with the x, I do the opposite of it. So I'm going to add 4 to all my x's. So I did the x plus 4. And now those are my points I'm going to graph. So if it's inside, I do it to the x. Like the last one, it was outside, so I did it to the y. So my points are 4, 0, 5, 1, 2, and 13, 3. And you'll know it works when you hit the little graph and you get a nice little graph. Let's say I just put a point wrong. Let's say I did 12, 3. And I hit that little graph. See how I get this messed up graph? I know I made a mistake at that point. So go back and fix something. So normally you're not gonna get a clean graph if you messed it up in your points. Normally you're gonna get something that looks kind of crazy. So that's how we get that. The only difference between this question, the part 2 or type 2 problems and the type 1s, the type 2 just has you do more transformations to it. So in this case, I got something on the outside and I got something on the inside. So I'm going to do 2 transformations to my problem. But again, I'm still going to start off with my same 4 points. 0, 0, 1, 1, 4, 2, 9, 3. But now I have 2 transformations I have to do. This equation has a 3 on the outside, and then it's x minus 2. So I'm going to do x plus 2. So this becomes 2, 3, 6, and 11. And then my outside, it's 3 times y. So that's 0, 3, 6, and 9. Because I'm going to multiply the y's by 3. So this goes with those transformations. Yeah, if it's a square root, I'd always use those points to start it. And then we're doing the transformation to it. So there's other ways to do this topic. If you could figure out where the starting point is, you could start off with the 2, 3, 6, 11 and be fine. The problem is then you have to figure out what you're starting with. And doing it with the transformations, you're always starting with that parent function, which makes it nice and easy. And then you're just manipulating your answers. So it kind of takes away those steps of trying to figure out where you're starting, which is always harder for people to do. I will tell you, for about 15 or so years of all my teaching, I never taught it this way. I actually taught it find the point and graph it out. And then as much as everybody seems to hate that Common Core thing, one of the big things in Common Core that came out of it was to work on transformations and understand how a parent function moved. And when I started doing research into that and understanding it, it makes all this stuff a lot easier if you understand how to do the transformations. So sometimes that Common Core is actually a good thing, even though everybody seems to not like it. So we graph those points. So it's 2, 0, 3, 3, 6, and 11, 9. And we graph it, and you get the nice curve. All right, we're going to do one more of these, and then we're done. All right, so same thing. We'll start off with my same parent function. So 0, 0, 1, 1, 4, 2, and 9, 3. Now this one, my changes, so I have 2 square root of x minus 3. They're both on the outside. So I'm going to do 2y first. So 0, 2, 4, and 6. And then I'm going to do the y minus 3. So this becomes -3, -1, 1, and back to 3. So my points that I'm going to graph are the final points over here. So it's 0, -3, 1, -1, or 1, and 9, 3. And again, we got our nice little curve, so we know it's most likely right. And that's the end. So we did 16 topics. So between this and the Monday class, I covered 31 of the topics in section 5.1. So you should be able to do all the topics in section 5.1 now. We'll do, remember there's Monday's Labor Day, so there's no class on Monday. we will have class next Wednesday. So Wednesday, and then the week after, I'll be able to finish up section 5.2. And then the week after that is actually our first test on chapters 1 through 5. So my suggestion would be before class next Wednesday to make sure to try to get section 5.1 section 1 of chapters 1 through 5 done. And then we're going to start working on the section 2 of chapters 1 through 5 on Wednesday. Any questions? No? I will see you guys next Wednesday.
Have a good one, Mr. Baker.
You too.